In this recording, we'll discuss the nephron. So the nephron is the functional unit of the kidney, and it does have two main components. We've got the renal corpuscle and the renal tubule. Now, the renal corpuscle specifically is responsible for filtering blood, and y'all, it filters a lot of blood. We are talking filtering your entire blood volume, all 4 or 5 liters of your blood, 60 times a day. 60 times a day, y'all. The corpuscle does have two parts. You've got the glomerulus and the glomerular capsule. The glomerular capsule sometimes is known as the Bowman's capsule, and that's usually the term that I use. That's just what I'm most familiar with. That's what I learned. So if I throw around Bowman's capsule, just know that it's the same thing as the glomerular capsule, okay? And then we've got the renal tubule, okay? So basically where the Bowman's capsule ends, that's where the renal tubule starts, and it runs all the way to the collecting duct. And it's just what it sounds like. It's a tube. It's going to take the filtrate that we have created. It's going to run it through the tube. We are going to modify that filtrate a little bit, and then we'll dump it all into the collecting duct at the end. This is composed of simple cuboidal epithelial tissue. Hopefully you remember the main functions of the simple cuboidal tissue. We've got a lot of diffusion, secretion, reabsorption, all those different types of transport are going to be happening at this renal tubule. This is kind of what it looks like with this whole thing, this whole picture. This is basically one nephron. Okay, we've got the corpuscle, and then we've got the renal tubule. It is very windy and snaky and all that good stuff, and it's going to stop here at the collecting duct. Okay, now let's talk about specific functions. So the renal corpuscle, remember, two parts, glomerulus and Bowman's capsule. Specifically, the glomerulus is a group of looping, fenestrated capillaries, right? That's a lot of good adjectives there. But they're capillaries, y'all. They carry blood. They are fenestrated. Hopefully you remember what that means, just in case you have forgotten. That means they're very leaky, okay? They are very good at letting substances escape. Or if you like the term permeable, that's okay as well. We are going to be taking a lot of things out of the blood at the capillaries, and we're going to be putting them into the glomerular capsule, that Bowman's capsule. How are we able to do this? It's because these capillaries, the glomerulus, it's under high hydrostatic pressure. Now, hopefully, you remember that hydrostatic pressure is basically your blood pressure. Okay, we've got high hydrostatic pressure at the glomeruli, which is just plural for glomerulus. Okay, your glomeruli, because of the high hydrostatic pressure, remember, what is hydrostatic pressure? It's the pressure that forces fluids and solutes out of the capillaries. Okay, so we've talked about hydrostatic pressure before, forcing fluids and things out of capillaries into like your interstitial space. Now we're specifically pushing fluids and solutes out of the capillaries, the glomeruli. We're pushing that fluid into a very specific place. It's going to go into the Bowman's capsule. Okay. So all of this hydrostatic pressure, we're going to push fluids from the capillary. It's going to enter the Bowman's capsule. I know, I keep saying the same thing because I need you to get it, all right? These Bowman's capsules, all right, they are also going to contain podocytes. These are special cells that have little extensions. They're called foot processes, all right? Podo basically means foot. These podocytes basically kind of surround the glomeruli, kind of wrap around them, and they form what are known as filtration slits. Okay, now filtration. What is filtration? That is literally the process of pushing fluids and solutes and substances out of the capillaries into the Bowman's capsule. Okay, that's what we mean by filtration. These slits, these filtration slits, are helping us regulate what can enter into the Bowman's capsule. Okay, so remember, we are not taking blood from the capillary and putting it into the Bowman's capsule. All right. Anything that enters into the Bowman's capsule, you cannot call it blood. It's called filtrate. Okay. It is not the same thing as blood. It's not even the same thing as plasma. We can't even call it plasma because we are regulating what is coming out of the capillaries, and we are leaving things in the blood, right? Red blood cells do not belong in your filtrate. White blood cells do not belong in your filtrate. Okay, so we're very particular about what can come in or come out, I guess I should say. Now, did I say all the words? I think I said all the words. Let's look at a picture. Okay, so here's what the renal corpuscle itself looks like. We've got the glomerulus in the center. All of these red blood cells, you can see they are red blood cells, the capillary, excuse me. You can see they are covered in these podocytes with their little feet extensions. We've got a blown up picture here. You can see much better the podocytes themselves, these little foot processes, and then you can see all these little slits. You can see the small spaces where there would be room to squeeze through, but these are really, really small, skinny spaces. So a lot of things just are too big to push through the slits. There are a lot of things that do not belong in the Bowman's capsule. They should not be in the filtrate. But if you do belong, if you are water, if you are sodium, if you are glucose, things like that, once you get filtered from the glomerulus and you get pushed into the capsular space of the Bowman's capsule, which is what this is, this whole little, it's kind of like a little hat, little cap, okay? You would then, as the filtrate, move directly into boop, the renal tubule. Specifically, the first part of the renal tubule is just called the proximal tubule. Okay, you'll see proximal and distal tubules. Proximal meaning closer to. What are we being closer to? We're talking about being closer to the glomerulus itself. Okay. All right, so that's kind of what we're talking about here. This is what everything looks like. Now, once we make the filtrate, we have to move the filtrate. We're going to go through the renal tubule. We are going to modify the filtrate as it moves through the tubule. There are three distinct parts. We've got the proximal tubule, the nephron loop, and the distal tubule. Each section is responsible for modifying the filtrate in its own unique way. All right, but this is kind of what we're talking about. We said the first part would be the proximal tubule, and it's windy and all that kind of good stuff. All right, so let's see here. All right, so first part, proximal tubule, all right, no big deal. First and longest segment of the renal tubule, we have both straight parts and coiled parts or convoluted parts. You will probably see the term proximal convoluted tubule. It's the same thing, okay? So convoluted basically just means coiled, okay? But it's very common to see it called proximal convoluted tubule or your PCT. You're going to see that a lot. It's all the same thing, okay? So this section is the simple cuboidal epithelial tissue that we promised, and we've got a lot of microvilli. Ooh, now we've seen microvilli before in the digestive system. What was it used for in the digestive system? Oh, it was used to make a brush border to greatly increase surface area. Same exact purpose here, okay? Same exact purpose. All right, so what do we need to increase surface area for? Okay, there is going to be a lot of reabsorption that is going to happen in your proximal tubule. Okay, so we need to increase surface area as much as possible so we can maximize how much reabsorption we can do. Then we are going to move through the nephron loop. Now, you're going to see and hear the term loop of Henle. It's the same thing, okay? Sometimes you'll see LOH, something like that, okay? It's all the same thing. I just learned loop of Henle, so it just comes a little bit more natural to me versus like nephron loop. But again, exact same thing, all right? This is the next part. So these are continuous, okay? So I don't want you to think that there's I don't know, like a stop sign or something. Like it's just one big continuous loop, okay? The filtrate that enters here, okay, is actually going to be dipping down into the renal medulla. So the renal tubule, this loop of nephron, whatever you want to call it, okay, this part does dip down into the renal medulla, okay? You've got two parts. You're going to like these, y'all. You've got a descending limb and you've got an ascending limb. So you're going to go down and then you're going to come back up, right? Like that's not bad, right? Okay. Let's see. You go down and then you come back up, right? You go down and then you come back up. Okay. So your descending limb. Okay. You might hear it termed the thin descending limb. Because it actually is made of simple squamous epithelial tissue. Okay, so we do have a little bit of change there in tissue type. So simple squamous, those really, really thin, flat cells, compared to the simple cuboidal cells of like the ascending limb, the proximal tubule, all that kind of stuff. Simple squamous tissue is still good for diffusion, filtration, reabsorption, all those types of transports as well. It's just a different type of tissue. Now, as soon as you go all the way to the bottom of the loop, you got to come back up, and that's where you hit the ascending limb. Okay. Again, you might hear it termed thick ascending limb because we're back to the simple cuboidal tissue. I usually just call it the descending and ascending limbs. That's okay. Some nephrons could have a thin ascending limb as well, okay? That's not really going to be a major focus for us specifically. You might get to a later class or some sort of particular program that you're in. They might make a little bit bigger deal out of this, but honestly for us, this is really just the nephron loop or the loop of Henle, okay? All right, the last section, we've got the distal tubule. Again, also sometimes called the distal convoluted tubule, so the DCT. This has, again, both straight and convoluted or coiled parts. And this is the last segment where filtrate will pass through before entering into the collecting ducts. Several distal tubules will all empty into the collecting ducts, also known as the cortical collecting ducts, because they are in the cortex. Okay, so here you can see these little branches. These would be the ends of the distal tubules. Okay, so you can see how several distal tubules will dump all of the fluid into one collecting duct. One collecting duct. Okay. Now, the collecting system itself, okay, again, you might see the abbreviation just CT, okay. This is composed of the cortical collecting duct, which we just talked about. Okay, that will eventually turn into the medullary collecting duct because it's going to continue to go down, right? So we're running through the cortex, so it's cortical collecting duct. Oh wait, we're into the medulla now. Well, now it's the medullary collecting duct. And then, ooh, papillary collecting duct. Remember the papilla was the very bottom of the renal pyramids, right? So it's really just the same tube. Right? The name just comes from the location. All right? Are we in the cortex? Oh, we're the cortical duct. Are we in the medulla? Oh, it's the medullary collecting duct. Are we down at the bottom in the papilla? It's the papillary collecting duct. Okay? So I don't really want you to think that these are like completely separate things. Okay? It's really just based on the location. Okay? Now, once filtrate enters into the papillary duct, there was my thing. Okay, papillary duct. This is urine. Okay, this is now officially urine. Okay, you cannot call it filtrate anymore. It's PP. Okay, this is PP. Once we leave the papillary collecting duct, we will move through the papilla into the minor calyx. We've talked about already from the minor calyx, we'll go to the major calyx, and then we'll go to the renal pelvis, and then into the ureters, to the bladder, to the urethra, out of the body. Okay. I know that was a lot. Just our review slide real quick. We start at the glomerulus, we go through the proximal tubule, we go through the loop, up the distal tubule into the collecting duct. You can see most of these have the simple cuboidal tissue, but a lot of times the descending limb of the nephron loop is simple squamous instead. All right, a couple of more structures to talk about regarding the nephron and collecting system, all this nephron stuff that we've been talking about. Okay, so we've done the glomerulus, we've done the Bowman's capsule, we've done all the parts of the tubule, all that kind of good stuff. There's also this thing, it's called the juxtaglomerular apparatus. And y'all know I love saying the word apparatus, but juxtaglomerular is hard to say. We abbreviate JGA, y'all. Just go with me, okay? This has two parts, okay? You've got your macula densa. That's not really hard to say. And then you've got your juxtaglomerular cells, your JG cells. That's hard to say. Don't make fun of me. These are hard to pronounce sometimes. You find these at the transition point between the renal corpuscle and the distal convoluted tubule of the same nephron. Okay, now that's probably kind of hard to envision. So the next slide, let's look at our picture real quick. Okay, so this is your glomerulus, right? Okay, and this is the whole picture. Okay, so we are looking at one nephron. Okay, we're looking at the glomerulus and the distal tubule. See how close these things are to each other? This is the big picture, all right, like the blown up picture. Okay, so we've got the JG cells, the juxtaglomerular cells. Okay, those are the, I guess this is purple, these little purple ones. Okay, and then you've got these macula densa cells. Now, these macula densa cells are part of the distal tubule. Okay, these JG cells are actually part of your afferent and your efferent arterioles. Okay, but that should give you a little bit of idea of like where we are and like what we're talking about. All right, so we gotta go back. So your macula densas, okay, these cells are in contact with modified smooth muscle cells. Okay, that's what the JG cells are. They're modified smooth muscle cells. And again, these JG cells, these are found in the walls of the afferent and the efferent arterioles. So just to refresh, afferent arteriole, okay, efferent arteriole. A comes before E. So the blood goes through the afferent arteriole towards the glomerulus. Efferent arterioles take blood away from the glomerulus, okay? So we go in through the afferent, we go through the glomerulus, we come out through the efferent, okay? So, like, who cares? Oh, we totally all care, all right? Your juxtaglomerular apparatus, your JGA, helps you regulate your blood pressure. Your blood pressure, okay? As well as your glomerular filtration rate, which is basically how fast you filter. It does this by releasing renin, okay? Now, you already knew that your kidneys release renin. Now you know exactly where that happens. It happens at this JGA, okay? And just in case you have forgotten what renin does, and if you did, don't tell me, I'll cry, okay? This activates your RAS, your renin, angiotensin, aldosterone system, okay? So don't forget, angiotensin 1 has to get converted to angiotensin 2. We have the ACE inhibitor, angiotensin converting enzyme, okay? We've got this enzyme. Angiotensin 2 leads to the secretion of aldosterone, okay? And we'll also be secreting antidiuretic hormone, ADH. Both of these cause water and solute retention. Increased water increases your blood volume. Increased blood volume increases your blood pressure, okay? You've got to master aldosterone. If you have not, do it now, okay? All right, so back to our picture. Just again to remind ourselves, the JG cells, the modified smooth muscles, are going to help us regulate our blood pressure by releasing the renin. The macula densa cells, okay, are assisting with all that as well, okay? So JGA, There we go. Macula densa, JG. We're going to release renin. Okay? Why might we do that? Well, perhaps the blood pressure or the blood volume in these arterioles, maybe it's too low. Okay? These cells are going to notice that and be like, you know what? I can fix it. I can help fix it. Okay, you do technically have two different types of nephrons. Okay, they look a little different and they function just a tiny bit differently. You have cortical nephrons and you have juxtamedullary nephrons. Your cortical nephrons, this is the majority of your nephrons. About 80% of all your nephrons are cortical nephrons. Cortical referring to your renal cortex. Okay, these are going to produce dilute urine. Okay, these are the ones that we've basically been talking about all along. The renal corpuscles and the cortex, a little bit of the nephron loop, dips down into the medulla. Sometimes it doesn't. Sometimes the entire loop is within the cortex as well. That's okay. We have peritubular capillaries. Okay, so what are those? Peri, around, tubular, right, around the tube. Okay, these are capillaries that are going to surround your tubes, right, your nephron tubes, your renal tubules. This is how we're going to supply blood to all of the loops, okay, and this is how we are going to indirectly exchange materials through your interstitial fluid as well. So we can kind of soak up stuff from your interstitial fluid if we need to, okay. Now, we haven't really mentioned your juxtamedullary nephrons yet. What does that even mean, juxtamedullary? It basically means like right next to. Okay, so to juxtapose something basically means to put things next to each other. These are a lot less common, right? Like maybe 20% of your nephrons. The corpuscles are found in the boundary between the cortex and the medulla. Okay, so here we go, right? This one's much closer to this dividing line. Your cortical nephron, the corpuscle's like way up here, okay? So that's what we mean by juxtamedullary, like we're really close to this boundary. The loop of Henle goes way down into the medulla, like way down in there, okay? This is going to produce more concentrated urine. Okay, so like I said, they look a little bit different, but they also function just a little bit differently as well. So the cortical nephrons produce dilute urine, juxtamedullary nephrons produce concentrated urine. This is the blood supply of the kidneys. Okay, so we can see the branches and branches and branches off the renal arteries. We can go and go and go. We lead from the afferent arterioles. We said that's going to feed directly into the glomerulus. And then we take the blood back through the efferent arterioles. Okay. Peritubular capillaries, then the venules, and then the veins. Okay. So just kind of FYI. I do want to point out these numbers real quick. Okay. There's a little bit of a discrepancy between these guys. All right, so this only goes up to, where's my big number? Like 13 for the renal vein, okay? This one, that picture just didn't label the venules, okay? They're in there, they just didn't get labeled, okay? So just in case you were looking and following along, on that picture, renal vein was 13, and here I've got it listed as 14. But again, the venules, they just didn't end up in this picture labeled, okay?